Okay, today we are gonna start with important topic which is called Borel set. But first, we are gonna do a proposition which is important, but that proposition is about that we will have a smallest sigma algebra. So it says that let x be a set, okay, and we have A is another set, but of subsets of x, okay, subsets of x. Then the intersection of all sigma algebras on X that contains A is a sigma algebra. So it says that if we have many number of sigma algebras on set X that contains the set A, then the intersection of all those sigma algebra will again be a sigma algebra, and that will eventually be the smallest sigma algebra. We're gonna see that by example. But first, to prove this thing, I think very easy. The proof is very easy. Okay, so proof is I say that let S is equal to the intersection of I belong to suppose n AI, while each AI is a sigma algebra. Okay, so we need to show that this S, which is the intersection of all those sigma algebra, is a sigma algebra. Okay, so like very easy, clearly the empty set will be in the set S, clearly, because so phi belong to AI for each I. That's like very obvious. So this means that if it is in each I, this means that it will be the intersection. Okay, and then the second property is also very obvious. Okay, so the second property is let E belong to S. We need to show that the complement will also be in S. Okay, so if E belong to S, what does this mean? This means that E belong to AI for each I. Okay, now each AI is a sigma algebra. If set E is in sigma algebra, then the second property of sigma algebra says that the complement will also be in that sigma algebra. So this means that then the complement is also belong to I for each I. This means that clearly if it is in each I, this means that it belongs to the intersection of each. And so we showed the second property. And the third property is also very obvious, countable union. That we can do that very easily. Okay, but I'm gonna leave that, okay, because this is very easy. So our basic purpose of this proposition was that actually the intersection of all those sigma algebra which contain the set A will be the smallest sigma algebra. Okay, so to see that, we are gonna jump into the example. Okay, so example is definitely my, okay, I'm considering real line, and then I'm considering the subset of this, a set which is the subset of R. So 0 1 and 0 infinity. Okay, so now we are gonna actually have a sigma algebra on this set S, which will contain the set, this set, okay, this set A. So to construct a sigma algebra, definitely the first property in sigma algebra that empty set will be in the sigma algebra. Okay, so the empty is, we will include empty. That's how it will be, a sigma algebra. Now because sigma algebra that we are gonna construct on this set A, so definitely it will have the element of set A. So suppose if I consider the first element, so then by the second property the complement will also be in the sigma algebra. So what is the complement of 0 1? So it is minus infinity to 0 union 1 to infinity. Okay, and then I'm gonna consider the another element of this set A. Now what is the, so if that set is, so this means that by the second property again the complement will also be there. What is the complement of 0 to infinity? It is nothing but it is minus infinity to 0. Okay, now also if you think, okay, So now we are gonna see the union property as well, because the third property is that the countable union should also be there. So what is the union of this and these two? If we consider the union of these two, okay, so this union is nothing but actually we can see that it is R. Okay, so definitely this is R is there. Now if R is there, also what do you think about the so this is R. Okay, now what do you think about the union of 0 1 union minus infinity to 0? What do you think of union? So this union is nothing but this is minus infinity to 1. So we are gonna include that minus infinity to 1 as well. Okay, now that was the union of this thing. Okay, now if minus infinity over 1 is there, then we should know that okay, the complement of that element will also be there. So what is the complement of minus infinity to 1? What is the complement? The complement is nothing but it says the complement is 1 to infinity. So we are gonna include 1 to infinity in that set as well. Okay, so this means that now this whole set, okay, so that's just for this is for your understanding this one. So set is the smallest sigma algebra that contain the set A, we constructed by this way. So phi is there, 0 1 is there, and then the complement is there, and then also we include 0 infinity, complement is there, and then the union and everything. So that sigma algebra is a sigma algebra, but it is the smallest sigma algebra that contains the set A. We saw that. Okay, we saw that. What we did, we just expand this set A and we construct a sigma algebra on this set A by just considering the three properties. Okay, we say that if this element is in sigma algebra, the complement will also be in there. So then we will see, okay, if complement is there, then the complement and the set union should also be there. We saw that union is also there. So that's how we construct a sigma algebra, and that is eventually the smallest sigma algebra. You can have many sigma algebra that contain set A, but this is the smallest sigma algebra. I hope you understand. Okay, so now we have a foundation. So what we are gonna do now, we are gonna go and define the Borel set. So to do that, first I'm saying that okay, so I'm considering a set. Okay, so if we consider a set, okay, so suppose this set I denoted by psi. Okay, so I psi is that okay, E is a subset of R such that E is open. E is open. Now my question to you is this a sigma algebra? I'm just talking about this set. Is this sigma algebra? Is it a sigma algebra? Okay, is it a sigma algebra? So I would say no, this is not a clearly sigma algebra, because it is not a sigma algebra. It is not. Okay, because the reason is, if I take an element E belong to psi, then by the second property of sigma algebra means that xe should be also belong to psi, but xe is a closed set which is not in psi, because psi has only open set. So this means that this set is not sigma algebra, but we can construct sigma algebra on this set. Hey, how? So that's how that is called a Borel set. So Borel set is nothing but we say that okay, so we construct a sigma algebra on this set, which will have on the open set. So then the element of that sigma algebra will be actually a Borel set. So now if we construct a sigma algebra on this set psi, because if E is open, the complement will also be there. So we will include closed set, open set, countable union of closed sets, countable union of open set. So this is called a Borel set. Borel set is nothing but the element of the sigma algebra on the set of open sets. That is the sigma algebra. Okay. Now that is the Borel set. So I ask you this. Give me simple example. Is this if I ask you, is this interval? Is it a Borel set? You will say, of course, yes. Why? Because it is a closed set. So Borel set contains all closed sets, open sets, countable union of closed sets, countable union of open sets, countable intersection of closed sets, blah 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 blah. Okay. So Borel set is nothing. Borel set is nothing but the element of the sigma algebra on this set. Okay. On this set psi, which will have only open sets. Okay. So then the element of that sigma algebra will be called the Borel set. I hope you understand. I hope you get the idea. If you have any question, please do ask. Okay. So I think we are done, and we will continue. Thank you.